For most people, Artemis III is a headline waiting to happen. A return to the moon, astronauts on the surface again. A moment that feels nostalgic, symbolic, and reassuring. Proof that some things haven't changed. But that framing misses what's actually at stake. Because if Artemis III was simply about planting boots on lunar soil, it wouldn't look like this. It wouldn't involve so many moving parts, so many contractors, so many interdependent systems operating across vast distances. It wouldn't be taking this long, and it certainly wouldn't be this complicated. Artemis III is not designed to be a moment, it's designed to be a precedent. What makes this mission interesting isn't where it's going, but what it's trying to normalize. For the first time since the Apollo era, the goal isn't to prove that something can be done once, it's to test whether it can be done repeatedly, reliably, and without starting from zero each time. That's a very different ambition. Infrastructure doesn't announce itself loudly. It doesn't care about spectacle. It reveals itself slowly through standards, habits, and assumptions that future systems quietly inherit. Most people never notice it forming until it fails. Artemis III sits right at that inflection point. It's where exploration gives way to logistics, where heroics give way to coordination, where success is measured less by applause and more by whether the next mission is easier than the last. And that's why the delays, the cost overruns, and the quiet controversies matter more than they seem. They're not signs of incompetence. They're symptoms of a system being asked to do something new, to behave like infrastructure rather than an expedition. This mission is forcing modern institutions, governments, contractors, regulators, and engineers to operate together over long time horizons under constant scrutiny with no immediate payoff. That's an uncomfortable test in a world optimized for speed and short-term results. So the real question isn't whether Artemis III will land on the moon successfully. The real question is whether it will teach us how to stay. Because if it does, this mission won't be remembered as a return to the moon. It will be remembered as the moment space stopped being an event and started becoming a place. If Artemis III was simply about returning humans to the moon, the mission would be strangely over-engineered. NASA has landed people on the lunar surface before with far less technology and far fewer stakeholders. What's different now isn't ambition, it's intent. Artemis III is structured less like an expedition and more like the opening move of a supply chain. The mission's architecture prioritizes repeatability over novelty. Hardware isn't designed to be celebrated once and discarded, but reused, refueled, and integrated into future missions. That's a subtle but important shift. Apollo optimized for speed and symbolism. Artemis optimizes for continuity. One former NASA engineer remarked that Apollo answered the question, can we? While Artemis is answering, can we keep doing this? That distinction explains many of the frustrations around delays and complexity. Artemis III is laying the groundwork that won't be visible on the first landing. Its success won't be measured by the moment astronauts touch lunar soil, but by whether the systems involved can be invoked again without starting from scratch. In that sense, the moon is almost incidental. What matters is whether this mission establishes habits, standards, and dependencies that make future presence routine rather than heroic. Permanent infrastructure changes how risk is evaluated. A one-off mission can accept fragility because failure ends the story. Infrastructure cannot. Artemis III reflects this shift everywhere, from redundancy planning to mission sequencing. Consider how different this is from Apollo-era thinking. Apollo missions accepted narrow margins because there was no expectation of permanence. Artemis assumes follow-on missions by default. That assumption quietly forces conservatism. Systems must degrade gracefully. Failures must be survivable, diagnosable, and fixable, not merely avoidable. A revealing anecdote comes from discussions around lunar surface operations. Instead of maximizing exploration range, planners prioritize communication reliability and abort paths. That's not how exploration missions usually think. It's how infrastructure thinks. This mirrors transitions we've seen elsewhere. Early internet protocols assumed small, trusted networks. Once the internet became infrastructure, stability mattered more than elegance. Artemis III represents a similar moment for spaceflight. The mission is less interested in expanding boundaries than in making presence boring. And in infrastructure terms, boring is success. The most consequential questions Artemis III is trying to answer aren't scientific, they're logistical. How do you move mass reliably? How do you store fuel in space? How do you synchronize systems built on Earth but operating thousands of miles apart? A NASA project manager once summarized this bluntly: physics isn't our bottleneck, coordination is. That line captures the reality of modern space programs. We understand orbital mechanics well. What's harder is aligning timelines, interfaces, and responsibilities across organizations. Look at fuel transfer. It's not glamorous, but it's foundational. Without reliable refueling, permanence is impossible. Artemis III includes demonstrations that are far more relevant to future lunar operations than surface experiments. This is why comparisons to cloud infrastructure are apt. The value isn't in any single server, it's in reliable orchestration. Artemis III is testing whether spaceflight can move from bespoke missions to something closer to logistics management. That's not inspiring in the cinematic sense, but it's what makes presence durable. Apollo missions were vertically integrated. Artemis III is modular by necessity. Components are developed separately, launched separately, and assembled operationally rather than physically. This reflects a broader shift in how complex systems are built. Modularity introduces flexibility, but also fragility. Interfaces become critical. When something fails, it's often at the seams. Artemis III's architecture accepts this trade-off because modular systems scale better over time. There's an anecdote from early Artemis planning where engineers debated whether tighter integration would reduce risk. The conclusion was counterintuitive. Looser coupling reduced systematic failure. If one component slips, the entire mission doesn't necessarily collapse. This thinking mirrors modern software and supply chains. Monoliths are efficient until they aren't. Modular systems survive shocks better. Artemis III is effectively importing this philosophy into spaceflight. If successful, this approach sets a precedent. Future space infrastructure won't be built as singular achievements, but as assemblages, imperfect, adaptable, and resilient. That's a profound change in how we imagine space exploration. Beneath the surface, Artemis III is testing institutional behavior more than it's testing hardware. Can timelines slip without collapsing political support? Can contractors coordinate without a single point of authority? Can safety coexist with distributed accountability? One overlooked stress test is decision latency. In Apollo, authority was centralized. Decisions were fast, sometimes brutally so. Artemis III operates in a more negotiated environment. That's slower, but potentially more sustainable. There's a quiet acknowledgement inside NASA that future space infrastructure will always involve multiple actors with competing incentives. Artemis III is rehearsing how to operate under those conditions. What's being tested isn't whether humans can land on the moon. It's whether modern institutions, risk-averse, regulated, and distributed, can still act coherently when stakes are high and timelines are long. That answer matters far beyond space. At this point, it's tempting to ask whether Artemis III is worth the trouble, the delays, the cost, the complexity. But that question misses the point. This mission isn't the performance. It's the rehearsal. Rehearsals are inefficient. They expose flaws. They feel unsatisfying because nothing is finalized. But they're where systems learn how to behave under pressure. Artemis III exists to make future missions less dramatic and more reliable. If that sounds underwhelming, it's because infrastructure is supposed to be. Every mature infrastructure eventually converges on standards: technical, procedural, and cultural. Artemis III may quietly establish many of these without formal declaration. Standards emerge from precedent: how missions are reviewed, how failures are communicated, how interfaces are defined. Once established, they're hard to change. A useful analogy is early commercial aviation. There was no single moment when standards appeared. They accreted through practice. Artemis III is likely doing the same for lunar operations. Years from now, future missions may inherit assumptions set by Artemis III without realizing it. That's how infrastructure propagates, not through announcements, but through defaults. The difference between visiting and staying is enormous. Artemis III marks the inflection point between the two, not because it establishes permanence itself, but because it makes permanence thinkable. Presence requires predictability. You don't send people to places you can't reliably support. Artemis III is about proving that support chains can exist beyond Earth. Once that threshold is crossed, the narrative changes. The moon stops being a destination and starts being a location. That shift has implications for science, industry, and geopolitics. The landing is just the opening scene. Strip away the spectacle, and Artemis III asks a deceptively simple question. Can modern societies still build and maintain complex systems that don't pay off immediately? This isn't about technology, it's about patience, coordination, and institutional memory. If Artemis III succeeds, it suggests that long-term thinking is still possible, even in fragmented, incentive-driven environments. If it struggles, the lesson won't be about rockets, it will be about governance. That's why Artemis III matters even to people who don't care about space. It's not testing how far we can go. It's testing whether we can still commit to staying. Thanks for watching. If you enjoy hearing about stories in tech and you want to support the channel, the best thing you can do is to subscribe and like this video. See you for the next one.